Hey everyone, welcome back to the channel. In this video, we'll explore an advanced yet very practical concept in C++, Dynamic Casting and RTTI, or Runtime Type Information. You'll often hear these terms when dealing with inheritance and polymorphism, especially when you are working with base class pointers or references pointing to derived objects. By the end of this video, you'll understand what RTTI is and why it's needed, the role of dynamic cast, how type ID or type info work, the difference between static and dynamic cast, and a short mini project to see them in action. Let's get started. RTTI stands for Runtime Type Information. Normally, C++ revolves most things at compile time, but sometimes we need to know the actual type of an object while the program is running, especially in polymorphic hierarchies. That's where RTTI comes in. It allows your program to identify the actual type of an object at runtime, safely convert base class pointers or references to derived class ones. When you have a base class pointer pointing to a derived object, you might want to safely convert it back to the derived type. That's done using dynamic cast. For pointers, we write dynamic underscore cast and then type star, and inside the parentheses, we write the pointer. For references, we write ampersand. Keep in mind, the dynamic cast operator works only with polymorphic classes, that is, classes with at least one virtual function, and it returns null pointer if the cast fails. Let's understand safe downcasting with this example here. So we created a class base and a derived class. Then in the main we created a base pointer and a derived pointer, which points to the class derived here. Let's run and see the output. The cast succeeds because base pointer actually points to a derived object. If it pointed to a pure base object, the cast would fail. For example, here, if we wrote base, the output would have been cast failed because base pointer points to a base and not a derived class. Dynamic cast safely returns null pointer, preventing runtime errors. With the next example, we are going to understand dynamic casting references. When casting references, a failed cast throws a std scope resolution bad underscore cast exception, like in this example. Let me run it first, and you can see the same in the output. This is where we created our reference. Type ID helps us identify the exact type of an object at runtime. The syntax is very simple. You write type ID object dot name function. It returns a type info object that contains information about the type. This program is an example where we used type ID. For that, we must include type info header. Type ID star B2 detects the actual derived class type at runtime. That's RTTI in action. Let's see the output. This table here shows difference between static cast and dynamic cast. Let's now make a small program that detects object types at runtime. We are going to include our headers and then using namespace std. After that, we are going to create our classes and a function identify shape. So till here we created our classes and used inheritance. Now let's create our function identify shape. At last, inside the main, we are going to create different objects for circle, rectangle, and shape, and then call our identify shape function. Now I'm gonna save and run it. Perfect demonstration of RTTI plus dynamic cast to identify types at runtime safely. Fantastic work! You have now mastered dynamic casting and RTTI, essential for understanding polymorphism, safe downcasting, and runtime type checking in C++. If you have learned something new today, comment #RTTI master. Give this video a like, subscribe so you don't miss the next part. Thanks for watching.